Okay, we're on number 13. 13 says, how many solutions does the quadratic equation x squared plus 4x plus 8 equals 0 have? It's not actually asking you what they are. It just wants to know how many that it has. So I started by trying to find the solutions first, and then I can answer the question easily. We know it could have no solutions, 1 solutions, 2 solutions, and they can be real or imaginary. So I'm just going to figure out what they are, and then I can answer the question. So since this is a quadratic, if I can factor, that'd be the easiest way to go. So we can see that a is 1, coefficient of x squared, b is 4, and c is 8. If I were going to factor, I would need two numbers that multiply together to get a times c, which is positive 8, and then add to get b, which is positive 4. So let's see, 8 times 1 is 8, but 8 plus 1 is 9. That doesn't work. If I did negative 8, negative 1, it still wouldn't work. 4 times 2 is 8. 4 plus 2 is 6. That doesn't work. If I did negative 4 and negative 2, I would get negative 6 over here, so that doesn't work. Are there any other factors of 8? No. So can I factor this? No, that doesn't mean there's no solutions. It just means I can't find them by factoring, right? So I can always use the quadratic formula to solve a quadratic, or I can complete the square to solve a quadratic. Those will always work. I'm going to use quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah. X equals negative b or opposite of b. So if b is 4, we'll put it in negative 4 plus or minus b squared. So that's 4 squared minus 4 times 1 times 8 all over 2 times 1. So that's negative 4 plus or minus the square root of 16. 4 squared is 16. And then negative 4 times 1 times 8. Negative 4 times 1 is negative 4. Negative 4 times 8 is negative 32. All over, running out of room. 2 times 1 is 2. What kind of number am I going to have under that radical? It's going to be imaginary. Why is it going to be imaginary? Because it's going to be a negative number, right? Do I even need to go further to be able to answer my question? No. How many solutions am I going to get, and what kind are they? There's no real solutions. True. Well, actually, there's no real solutions, but this says no solutions, right? We do have solutions. They're just not real. 2 complex solutions, right? Complex is a real and imaginary number. So if we simplify that, negative 4 plus or minus, what is the square root of negative 16? 4i over 2, and then I could reduce both of those. Negative 4 divided by 2 is negative 2, plus or minus 4i divided by 2 is 2i. So it's negative 2 plus 2i, that's one imaginary solution or complex. Negative 2 minus 2i, that's a second imaginary solution or complex number. So our answer would be option C, 2 complex solutions. Again, we didn't have to do all that simplifying, but since we're reviewing, might as well, right? 14. The graphs of functions f of x equals x cubed minus 4x and g of x equals negative 2x minus 4 are shown below. Okay, this must be the x cubed minus 4x. It has 2 turning points, and we know if our degrees are 3, the maximum turning points we could have is 2. This is a straight line, which negative 2x minus 4 as a degree of 1, that makes a straight line, right? And it really doesn't even matter once we read the question and see what it's asking. But just to point that out, remember in behavior too, On the left side of my graph, and this question has nothing to do with this, but it's a good time to point it out. If I were to ask you what's the end behavior of this side, we would say as x is approaching, what is x approaching on this side? Negative infinity. And what is y approaching? Negative infinity, right? My x's are getting smaller, my y's are getting smaller as my graph goes in the direction of this arrow. Again, this question does not ask you anything about it, I'm just pointing it out. On the right side of my graph, as x approaches positive infinity, y approaches positive infinity. Good. I'm so glad the arrow went off. If I'm just talking about this cubic function with two turning points, remember this is a relative maximum, this is a relative minimum, and I asked you what is the domain of that cubic function, what would you say? All real numbers, right? Is there anything, any number, negative, positive, square root, fraction, whatever, that I could not plug in and simplify? No. So all real numbers. Graphically, you can see there's no x value that won't be somewhere on that graph. What would my range be? All real numbers, right? And I'm just talking about the cubic function. What if I was talking about the line? What's my domain? All real numbers. What's my range? All real numbers too. Okay. Anyway, let's answer the question that asked. Which statement is true about the real solutions of the equation? Now remember, if I was just given one graph, the solutions are where it crosses the x-axis. Okay? But I'm given two graphs, and it wants to know the solution. So the solution is, at what place does it make
so funny the way you went. Not that one you got hit.
When I have two functions or more on a graph, I'm talking about a system. So the answer is, where do the two graphs cross? Because that's the one ordered pair that's going to satisfy both functions. Okay, if I plugged in x and y, it would make sense. There may be more than one location that they intersect. But in this case, my graphs intersect only in this one spot. So at -2, 0, right? Mm-hmm. And they just call it -2. So x value of -2 is the solution. Again, if I just had this cubic function, and I said, what are the roots? What are the zeros? What are the solutions? Remember, that's asking where does it cross the x-axis. So that's D would get you there because it crosses at 2, 0, and -2. But that's the solutions of only the cubic function. All right. The linear function, it only crosses at -2. So what do they have in common? They're only one spot when x is -2. All right. Number 15. The expression 4i cubed times the quantity of 2 plus I times the quantity of 5 minus I simplifies to a complex number in the form a plus bi. What is the absolute value of b? The absolute value of b. Okay, so remember that I squared is equal to what? Does anybody remember? -1. So whenever I see an I square, I've got to substitute in a -1. So don't forget that when you're talking about imaginary numbers. So what I'm going to do is I'm going to rewrite this, and I'm going to put 2 plus I and 5 minus I in brackets, those two binomials. Whoops, that's supposed to be 2 plus I. And I'll FOIL those, or distribute, if you will. And then I'll distribute the 4i cubed in at the end. So first times first is 10. Outer times outer is -2i. Inner times inner, so that's positive I times 5 will be a positive 5i. Last times last, positive I times negative I is -I squared. Let me clean that up a little bit. So 4i cubed times 10 minus 2i plus 5i. I'm adding and subtracting that, so that's not I'm not squaring the I. That would be plus 3i. Now minus I squared. Let me do this over here on the side. Minus I squared. We know when we see an I squared, we have to replace it with a negative 1, right? So I'm subtracting a negative 1 because of this minus sign. So technically, what am I doing? Adding 1. And then now I have like terms again. I have 10 and 1, so I can add those together. So 4i cubed, open parentheses, 10 plus, or I'm sorry, 11, because 10 plus 1 is 11. 11 plus 3i. Now I can multiply. I can distribute the 4i cubed. 4i cubed times 11 is 44i cubed. 4i cubed times positive 3i is positive 12i to the 4th power. Now you might be thinking those i's aren't squared, so I don't have to put a negative 1 in there. But does I cubed contain an I squared?
Hey, how do you get 44?
Because 4 times 11 is 44. Okay? I'm going to show you over here on the side what I'm going to do with I cubed and I to the 4th. Okay?
So we need to separate it?
I distributed the 4i cubed.
No, I'm talking about the cube.
Oh, yeah. Yeah.
Separated.
Right. Would you agree that I cubed is the same thing as I squared times I?
Yeah.
Okay, right? So for the I squared, I'll put in a negative 1. And then for the I won't, because it's not squared, right? And I can't get an I squared out of I. So that would be negative 1 times I is negative 1i, or just negative I. So for 44i cubed, I'll write 44 times negative I, and I'll come clean that up in a minute. Plus 12. Let me do the I to the 4th. Would you agree that the I to the 4th is I square times I square? Yeah. So I squared is negative 1 times negative 1 is a positive 1. So instead of 12i to the 4th, it'll be 12 times positive 1, which is 12, right? So 44 times negative I is negative 44i. Positive 12 times 1 is positive 12. It's said in the form a plus bi, right? I've got it bi plus a form. So my a should be the number that doesn't have an I with it, imaginary. So I'll write the 12 first. It's positive. 44i is negative, so minus 44i. But did we answer the question?
Yeah.
Yes.
Are you sure?
No, not yet. The absolute value of B.
Right. What is the absolute value of b? So b is negative 44.
So the absolute value is 44.
Right. The absolute value is positive, right? It's the distance from that number to 0. So our actual answer is 44. Be careful of that on the FSA. A lot of times, I know y'all heard this your whole school and life, but you think you know what you're asking, just like that. Honestly, oh no, I didn't. I did it right. I was going to say, when I did this the first time, I just put 12 minus 44i, but I didn't. Looking at my paper, I have 44 there. But I could easily have made that mistake thinking that's the answer, and if it was multiple choice, I guarantee you it'd be there. So just always go back, read the question again. Did you answer the question that was asked? Coolio? Why are you looking at me crazy?
No, look at what?
Number 16. Next page. What are the solutions of the system of equations? Y equals x squared minus 6x plus 8 and x minus y equals negative 2. Okay, y'all know we've done systems in here before, but it was two linear equations, like two lines. Where do they intersect? That ordered pair is the solution. Or if they're parallel, they never intersect, so they're no solution. Or if we graph them and they're the same exact line, all of their ordered pairs are in common, so that's infinitely many solutions, right? But this is a quadratic function and a linear function. So what you could do if you had graph paper or were really good at drawing graph paper, you could graph both of these. Remember, quadratic is going to be a parabola. This one's going to open up. This is going to be a line. If we put it as y equals mx plus b, we could find our y-intercept and then our slope and figure out where they cross. Well, we could do that. All right, they're going to cross somewhere. That ordered pair where they cross would be the answer. Or algebraically, and this is what we haven't done, we did not find the solution of a quadratic and a linear function, but it's really easy, okay? Get both of your equations set equal to y if not already. So get the y isolated. So on my top equation, my y is isolated. My bottom one isn't. So let me do that real quick. Well, I'm going to subtract x and make sure this y is negative. So negative y equals negative x minus 2. Divide by negative 1, which is of course going to change all these signs, right? So negative y will become positive y, negative x will become positive x, negative 2 will become positive 2. So again, I could graph both of those and be on my merry way. But I'm not drawing a graph, and if I want to know exactly where they cross, and I don't have a piece of graph paper, then probably that's not going to be the route I want to choose. So once I have both of my equations set equal to y, take whatever y is equal to, because you want to know when these two equations are equal, right? So take what y is equal to in this equation. Exactly. Set it equal to what y is equal to in this equation. Because I want to know, when is this equation equal to this equation? I can only have one equal sign in the problem. So you want to get it set equal to 0 and then go from there. In this case, I can tell once it's set equal to 0, I'm going to have a quadratic, and I know how to solve a quadratic, right? So it kind of just depends on the problem, but more than likely you would also have a quadratic. Alright, so I'm going to get it set equal to 0. I'm going to subtract x from both sides, and I'm going to subtract 2 from both sides. So that in this equation, or in this problem, on my right side I have 0. And then on my left side I have x squared. Negative 6x minus x is negative 7x. And a positive 8 and a negative 2 is a positive 6. And if I can factor it, I'm going to, and I think I can. Yeah, negative 7x here, positive 6 here. So A is 1, B is negative 7, C is positive 6. Will I have to divide and slide on this if it is factorable? No, because A is a 1, right? But remember, if A is not 1, you got to divide or you got to slide. But we won't have to in this one. And I need two numbers that multiply together to give me A times C, which is positive 6, and add to get B, which is negative 7.
Negative 6 only?
Negative 6 and negative 1. Negative 6 times negative 1 is positive 6, and negative 6 plus negative 1 is negative 7. Winner, winner, chicken dinner. So my factors are x minus 6. Those of you who are watching the video, that was from my 5th period, not your class. And x minus 1. Now, those are my factors, and we don't have to divide and slide because A is a 1. If I did, I'd need to make sure I do that. But I haven't solved yet, right? So if I'm using factoring to solve, what would I do now? Set each factor equal to 0. So I'll set x minus 6 equal to 0 and x minus 1 equal to 0. Over here I'll add 6 to both sides, so one of my solutions is x equals 6. My other solution, I'll add 1, is x equals 1. Is that answer in the ordered pairs? it's obviously going to cross, they're going to intersect in two places, right? Which even where I drew up here, and I don't even know what they look like because I didn't graph them, but I was just thinking, mine crosses in two places, and the one that I sketched, even not even knowing what it would look like. So that makes sense that could happen, right? So I only found the x values of the ordered pairs. So I found option B, but let's just double check and make sure. This is x of 6, this has an x of 1. If I plug x equals 6 into either equation, I should get 8. So let me see. If x is 6, so it'd be 6 minus y equals negative 2. Subtract 6, negative y equals negative 8. Divide by 1, y is positive 8, right? So that makes sense there. If x is 1, let's plug 1 in. I'm just choosing the bottom equation because it's linear. I could do the top one because it should be the same for both of them. So when x is 1, that'd be 1 minus y equals negative 2. Subtract 1. Negative y equals negative 3. Divide both sides by negative 1. Y equals positive 3. So B works out for both of them. Right on? Crouton. 17, given the functions f of x equals x squared, so we know that's a quadratic, it's actually a parent function of a parabola, and g of x equals x minus 2 quantity squared plus 1, how can the graph of g of x be obtained from the graph of f of x? If you read all those answers, they're just talking about translation rules. So we know f of x is the parent function, right? If we graphed it, its vertex would be at 0, 0. It would have an ordered pair at 1, 1, and at 2, 4. And it's reflected, right? It would also have an ordered pair at negative 1, 1 and negative 2, 4. It's a parent function of a quadratic that opens up. It wants to know how function g would be different than the parent function. Do y'all remember the vertex form of a quadratic? Y equals a, open parentheses, x minus h, quantity squared plus k. Remember, a tells us, and y'all need to make sure you know this for the FSA, okay? Faux show. A tells us if it opens up or down. If it opens up, A is positive. If it opens down, A is negative. What's our A in this in function g? 1. It also tells us if it's going to be a stretch or a compression. If the absolute value of A is greater than 1, it's going to be a stretch. If the absolute value of A is between 0 and 1, so it's usually like written as a fraction or a decimal, then it'll be a compression. That's where it's wider than the parent. Stretch is where it's more narrow, right? So a stretch would be more narrow. Compression would be wider. We know all that from A. K tells us if it's going to move up or down. If K is positive, the parent function will shift up. If K is negative, the parent function will shift down. And H is the one that's opposite of what it would seem like, and it's because you're subtracting H. So it's changing the sign of what H is. So if H, this is the left or right. If H is positive, it will shift left. And if H is negative, I didn't mean to write -1 there, just negative, it will shift right. This positive seems like it would go to the right side of the graph because it's positive, and when you go to the right, you increase. But because the formula subtracts H, it's the opposite of what H originally was. So in this case, 1 tells us our graph is going to shift up 1. -2, it's going to shift right 2. This is opposite. And it's going to open up, and it's not going to be either a stretch nor a compression because it's going to open at the same rate as the parent, right? So if I just had to graph this from my parent function, I know I would shift up 1 and right 2, and I know it would open at the same rate. So if I had to sketch it, I can do like that without doing anything else. But that's not what the question asked me. Option B, translate the graph of f of x to the right 2 units and up 1 unit. So option B. To be or not to be? That is the question. Try not to be a dork on the recording. I just can't help myself. It's how I roll. Fast and out of control. Again, I apologize. I know, can't help it. Okay. Number 18. Which function best represents the graph below? Okay. How many turning points does this graph have? 3, right? Right here, there's 1. That's a minimum. We got a maximum. We got a minimum. Is this considered a turning point? No, it's not. Because it never actually changes directions. It just kind of goes a little to the side. Not even straight. It just goes a little to the side and then still up. So that cannot be considered a turning point. So we know that our function has to have at least 4 degrees in it. Am I right? Because remember, your degrees, your turning points is a maximum of 1 less than the number of degrees. So this has to have at least 4 degrees if there's 3 turning points. It could have more than that, but it can't have 3. It's got to have at least 4 or more. So how many degrees does A have? 2, right? Because if I multiply my x's together, I'll get x squared. That's a quadratic. Can't be a quadratic. It's got to have at least 4 degrees. How many degrees is B going to have? 3, because x times x times x is x cubed. That's a cubic. Can't be a cubic. I need to have at least 4 degrees.
C.
How many degrees is C? Well, I've got 2 there. That's x squared. That's x cubed. And then I'm going to multiply those together. So that's going to be 6, right? But also on this one, same thing, but I have this x, so that's going to be 7. So it's going to be one of those. I'm going to have to do a little more research to figure out which one. Okay? So what I did was I plugged in some ordered pairs. Like I can see on the graph, like there's a good one right here, x is -1. Here, x is 0. Maybe plug those x's into both of these and see which ones work. That's what I did. But I know it's not A or B. So let me try option C. And I'm going to plug in, I'm going to do an easy one, when x is 0 and see what y is. Because on my graph, when x is 0, y is 0, right? So I get 0 plus 1 quantity squared times 0 minus 2 quantity cubed. That's going to be 1 squared times -2 cubed. 1 squared is 1. -2 cubed is -8. So when x is 0, y is -8. Is that an ordered pair on the graph that you see? 0, -8. Is that on my graph? No, so I'm thinking it's probably not C unless I made a mistake. I don't want to trust myself. I want to check out D to see if I plug in 0, will I get 0? And then I'll feel a little better about it. Okay? So let's do... Plug in a 0. 0 times 0 plus 1 quantity squared times 0 minus 2 quantity cubed. So that's 0 times 1 squared is 1. We already did -2 cubed is -8. 0 times 1 times -8 is 0, right? So when x is 0, y is 0. Is that ordered pair on my graph?
Yep.
Yeah. If you just wanted to double extra check yourself, you could plug in when x is -2 into option D, and you should get when x is -2, y is 0. And it looks like 2, 0 is also an ordered pair, so plug in a positive 2 and see if your y is 0 if you just want extra check. But I'm feeling pretty confident, and I have the answer key, that D is my answer. But see how we easily isolated A and B by knowing the facts of those turning points? If not, we could have gone and done all of them and plugged in when x is 0 or when x is -1 or when x is 2. Okay, if we had to. Number 19. An apartment complex has 200 apartments available to rent. The function P of x equals -8x squared plus 3000x minus 75,000, here we go with another quadratic, represents the monthly profit earned for renting x apartments. What domain of P of x is reasonable in the content? So domain is all of your possible x values, right? And what did x represent? Right, it's the number of apartments, right? Well, how many apartments are available to rent?
200.
Okay, so x is the number of apartments. Can you have a negative number of apartments?
No.
No. And our y is the monthly profit. Of course, you can have a negative monthly profit, but you can't have a negative number of apartments. So I only need this first quadrant, right? Right?
Yes.
Okay, so domain is going to be number of apartments because those are my x values. Do all positive integers make sense? No, because does my apartment complex have 500 apartments? 1,000? No, it only has 200, right? So all positive integers wouldn't make sense. Even though we're doing this in the positive quadrant, it's not going to be all positive numbers.
So would it be all whole numbers less than or equal to 200?
I'm wondering, let's see. What are all positive real numbers?
No, because it's only 200.
Exactly, again. All whole numbers less than or equal to 200.
Maybe.
Maybe.
No.
So,
Because wouldn't it be a negative? Can't do that.
all whole numbers less than or equal to 200.
Oh, yeah. Okay, yeah. Good one. Yeah, see.
Why wouldn't it be D, all positive real numbers?
Because there can be a negative in the left conflict.
Well, yeah, exactly. Good job, Brooke. Whole numbers are not negative. It starts at 0. 0, 1, 2, 3, 4, 5, like 0 in accounting numbers. All positive real numbers, a real number is positive real numbers though, so it does keep it positive. But a real number is a fraction, a decimal, or a radical. Can I have 2 square root of 3 apartments?
No.
No. So C is the answer. 20. Some of my classes learn focus and directrix.
I don't have that.
It's teeny tiny right below 19.
Oh.
Some of my classes learn focus and directrix. Some of my classes didn't. Okay. I'm going to try to teach 20 kind of like a mini lesson. Currently, as I'm recording this, it may not be true when you watch it, but as I'm recording this, on the left-hand side of the board, there are some notes that if you took focus and directrix notes, you probably have. If not, we're going to kind of do a mini version of that right now. So hopefully on the back side of your paper, you don't have anything written on it, because I'm going to kind of take this whole piece of paper to answer this question and give you a super fast mini lesson. The equation x plus 1 quantity squared equals 4 times open parentheses y minus 2 is a parabola. What is the y coordinate of the focus of the parabola? Okay, we know a parabola is a U shape, right? When we do quadratics, it opens up or down. When we factor the inverse of a quadratic, we get a sideways parabola. Okay? So there's 2 different equations for parabolas when written in this form. One of them is going to be for the up and down parabola. One of them is going to be for the sideways parabola. Is it opening left? Is it opening right? All right? So let's write down those 2 functions, or those 2 functions. They're not given to you on the FSA, like on the reference sheet. You have to know them. There's some similar things about them, so if you figure out those, it's not too bad to memorize. but one of them is y minus k, quantity squared, equals 4p, open parentheses, x minus h. This is the formula. Notice that y is being squared in this one, okay? And when we're used to working with, we just took notes on it a minute ago, the vertex form of a quadratic, which the vertex form is y equals a times x minus h quantity squared plus k. We know that's a parabola that opens up and down. We're used to dealing with that. Notice in that equation, y is not squared, okay? In this equation, if I multiply these out, y minus k times y minus k, my y would be squared. So I know because y is squared, it's not the up and down parabola, it's the left and right parabola, okay? So if it opens to the left, that would be because p is less than 0. You know how we have a tells us up and down? Well, if we multiply 4 times this number, that will give us the a. But whatever this is, if it's negative 1 times 4 is negative 4, and I'm using this formula, I know it's going to open to the left. It will open to the right if the problem's given to you in this way, where y is squared and p is greater than 0. The other equation, this is the one that's used if your parabola opens up or down, is x minus h quantity squared. So we still have an x minus h, just like we did in the other one, but this time it's what's being squared. Notice x is squared here. In an up and down parabola, x is what's being squared. Okay, that's how I remember which one it is. Equals, it also has a 4p, and it also has a y minus k, but this time y minus k is not being squared, and the left and right one, it was being squared. So this will be your formula for parabola that opens up or down. It opens up if p is, remember, p times 4 will give us our a, and we know if a is positive, it opens up, so p would have to be positive for that to be true, or greater than 0. It opens down if p is less than 0, and again, it's this formula where x is squared. So say you have a number here. Say this is a number 8, not 4p. It's the number 8. And you're like, what? I got to know what p is. Because p is important for the focus and directrix. If you have to know what p is, we know that it's going to be 2, because 4 times 2 would give us 8, right? But what if it's a weird number like 7? 4 times what gave me 7? It's going to be a decimal or something. So if you need to find p, which chances are you will, set the number, I don't know how else to say this, that is in 4p's spot equal to 4p and solve for p. P is the focal length. And you're like, well, what is focal length? I have no idea what focal length is. So let me show you real quick. A lot of fluffy points being lost today. Lots of fluffy points. If you have a parabola, whether it opens up, whether it opens down, whether it opens left, or whether it opens to the right, say I'm going to have it opens up. Say my vertex is at -2, 1. Okay? And say my directrix is a horizontal line at y equals -1. Then my focus would have to be at -2, 3. Directrix, D-I-R-E-C-T-R-I-X, directrix, and then this is the focus. So when you have a parabola, the vertex, the focus and the directrix have a relationship, okay? The vertex is halfway between the focus and the directrix. So these two distances are equal, the focus and the vertex and the directrix, okay? The distance between the focus and the vertex is called your focal length. So that is P. In this case, that was 2 units. So P would be 2, and since it opens up, P would be positive. The distance between my vertex and my directrix, which is the line, has to be exactly the same as the distance between the focus and the vertex. So it's 2 units, and because my parabola opens up, it's positive. Okay? So when I need to find the P, that's because I need to know the distance. I need to know what was the distance between the focus and the vertex and the focus and the directrix, because then I'll know, if I know what my vertex is and I know the focus, I know how much to count up to put the focus, or how much to count to put the directrix. Okay? Now, if your graph opens to the side, say my vertex is here, the focus is always like inside the U, inside the bowl. So if my focus, my vertex is at 2, 1. If my focus was at 3, 1, how many units was it between the vertex and the focus? 1, right? So P, and since it's open and to the right, it means that P has to be greater than 0, so that means it'll be +1, not -1. That means my directrix is 1 unit also. And your parabola can never touch your directrix, so it would be a vertical line when it opens left or right. Okay? Vertical lines are always x equal wherever it crosses the x-axis, so it would be at +1. So, now that you know what focus and directrix mean, let's get to the question that was asked. The example, or the question says, the equation x plus 1 quantity squared equals 4 times y minus 2 is a parabola. What is the y coordinate of the focus of the parabola? So we got to figure out what the focus is. So the equation was x plus 1 quantity squared equals 4 open parentheses y minus 2. Well, we can see that x is what's being squared, right? So just like up here, x is what's being squared, so we know it's going to open up or down because x is what's being squared, not the y. So we know it's going to open up or down. If p is less than 0, it'll open up. If p is greater than 0, it'll open up. If it's less than 0, it'll open down. I don't have to know what p is to know if this is positive or negative, right? It's going to be positive because something times something gave me this positive number, and it's 4 times something, and 4 is always going to be positive. So this tells me it's going to open up. What else can I figure out? My vertex, I forgot to point this out above. Your vertex is always at h, k. So this is x minus h quantity squared equals 4 times p times y minus k. Notice in this formula that it's subtracting h and it's subtracting k. When we do parabola's vertex form, it only subtracts the x minus h, right? So H is the only sign you have to change, but in this form it does both of them. So H comma K is where you find your vertex. So your vertex would be -1, comma, +2. I had to change the sign on both of them. Now, it's obvious that P is what? 4 times P gave me 4. What did P have to be? It had to be 1, right? But if it was something more confusing, I just take whatever's in 4P spot, set it equal to 4P, and solve for P. And it had to be positive. So we know if it opens up and P is positive, P is how many units to go up to the focus and how many units to go to the directrix, right? So if I can just sketch this real quick, I can figure out what the ordered pair of the vertex is. So I'm going to draw a neat little graph. My vertex is at -1, comma 2. I don't have to know how narrow and all that stuff it is to find the focus and directrix. So is at -1, comma 2. That's the vertex. I know it's opening up, right? I don't care how wide or thin. I'm just trying to find the focus and directrix. Since P is 1, that's the distance from the focus to the directrix. So the directrix never touches the parabola, so I know it's going to be down here. So P is 1. And then that's also the distance from the vertex to the focus, right? So can I figure out what that ordered pair of that focus is? -1, comma 3, right? Because I know my P is my focal length, so I can figure out how many units to go up or down. And the question said, what is the y coordinate of the focus of the parabola? I didn't want to know the whole ordered pair, I just want to know the y coordinate of the focus. So what's my answer? Y? +3, right? And there you have it. Make sure that you are using algebranation. This is by no means a complete review of what we've done all year. This is a good start of review for what we did at the beginning of the year. I'm going to hopefully make a quick trigonometry review video. We probably won't have time to do it in whatever class that you're watching this in. We may or we may not. If we don't, I'll definitely post it online on Edmodo. Please, please, please watch it. There was a lot of trig last year. It's something that needs to be reviewed as well as doing algebranation stuff. So look for that if we don't cover it in class.